Okay, so here's the second part to Unit 4, Lesson 1. We're going to drop down and look at example K, which is under double angle identities. So this is Unit 4, Lesson 1, Part 2 of the videos. So example K. Our example K looks like this. So we have sine of x plus cosine of x squared equals 1 plus sine of 2x. Okay, so I'm hoping that you have your identity sheet handy because these are going to be examples that are going to involve a double angle. Remember, in all of these identities, x represents an angle or an angle measure. So if you look at example K, you see that sine of 2x, x is being multiplied by 2, so therefore we have a double angle. That's why this is called the double angle identities. So as before, you can only work with one side of your identity or equation when proving or showing that this identity is true. And so, as always, pick a side to work with. Pick a side and stay with it. This particular identity, on the left, I notice that I have a sine of x plus cosine of x that is squared. That's a binomial squared. And 1 plus sine of 2x is pretty simple, but I do need to remember, if I look at my identity sheet, I'll notice that there is, under the double angle identities, an identity for sine of 2x, and that is 2 times sine of x times cosine of x. So if I work with the left side, I'm going to shoot for getting, if I can get the left side to look like 2 sine of x times cosine of x, then I will know that I have this piece right here. So, if I work with the right side, then I want the right side to end up looking like sine of x plus cosine of x squared. Okay, so let's see. On your worked out notes, I worked with the right side. Okay, so what I did was, we can do this. I'm going to replace, well, that's supposed to be a 1. 1 plus, I'm going to replace sine of 2x with its identity. So 2 sine of x cosine of x is going to be, now what we have is 1 plus 2 sine of x cosine of x. Okay, well, I want us to think about the left side. The left side, whenever you have a binomial squared, if I were to multiply this out, I would have a PST. A PST, perfect square trinomial factored, is a binomial that is squared. That's where the perfect square comes in. So if I'm looking at the right side and I need this to end up being a PST, what specifically do I need it to be? Well, if you look at this, if you were to multiply this out, your PST for this would be, let me see where I want to write this. Your PST for this would be sine squared x plus 2 sine x cosine x plus cosine squared x. I probably should not have written it there, but if you were to multiply this out, if you were to write this out twice and FOIL, this is what you would get. Well, if you look at that, notice there is something that shows up that we definitely need. I see that we have this 2 sine x cosine of x, which is good. So let's think about 1. Notice that when you multiply this out, you have this sine squared x plus this plus cosine squared x. Well, if you recall, 1 is the same thing. We have an identity of cosine squared x plus sine squared x equals 1. So what can I replace this 1 with? Oops, sorry. I didn't realize this was off the page. Okay, so cosine squared x plus sine squared x equals 1. So what I'm going to do is I'm going to replace this 1 with cosine squared x plus sine squared x. I have my positive 2 sine of x cosine of x. If I rearrange this into cosine squared x plus 2 sine x cosine of x plus sine squared x, this is the PST that is created when you square this binomial. So if this is a PST, then this PST can be factored into cosine of x plus sine of x squared. And so this is the process that we used to prove that sine of x plus cosine of x all squared equals 1 plus sine of 2x squared. Okay, let me just give you a little example, an example from Algebra 2, say, or Algebra 1. If you have, let me give you some examples of PSTs. So if you have x squared plus 4x plus 4. Oops, sorry. This is a PST. Okay. This will factor into 2 identical factors, x plus 2 times x plus 2, which can be written as x plus 2 squared. Okay. So even though this doesn't look as clean and neat as this PST, this is still a PST. Okay, what if I did not include this on your notes, I don't think, but what if could we have worked with the left side instead of the right side? So sine of x plus cosine of x squared equals 1 plus sine of 2x. If you multiply, if you FOIL sine of x plus cosine of x, if you square that, you get, like I did up here, sine squared x plus 2 sine x cosine x plus cosine squared x. And all the while, I'm watching what I have on the right, and I know that I'm trying to get all of this to turn out to be 1 plus sine of 2x. Well, if you notice your sine squared and your cosine squared, those two right there, sine squared x plus cosine squared x, can be replaced with 1, which is definitely something that I need. So I've dealt with this and this. Now focus on this middle term. 2 sine of x cosine of x is the double angle for sine of 2x. So I can replace this 2 sine of x cosine of x with sine of 2x, which is exactly what I was shooting for. And so they are, that process just proved that that identity is true. So how do you start? Just pick a side. Pick a side of your identity and just start working through and replacing things, perhaps with things that you know to be true. Manipulate the expression to write it in a different form. This is just going to require some trying and playing around with things to see where it takes you. So now let's look at let's look at which one do I want to do? Let's look at N. Let's look at example N. Okay, so example N, what do I have there? Okay, so example N looks like this. Tangent of theta equals 1 minus cosine of 2 theta over sine of 2 theta. Okay, so here's an example that I think is obvious to start with. In my opinion, it's obvious to start with the right side or work with the right side. And the reason why is because I have more to work with. When I look at the right-hand side and I notice that I have a cosine of 2 theta, I know that that is a double angle. 2 theta is a double angle. Sine of 2 theta also involves a double angle. So here's what I'm going to think about. I'm going to think or look at my identities. I'm going to actually come over here. My sine of 2 theta is 2 sine theta cosine theta. Okay, so that's what sine of 2 theta is. Cosine of 2 theta, there are, if you look at your identity sheet, there are actually 3 versions of double angles for cosine. And so now we have to decide which one do we want to try to use. Okay, well, I'm going to look at the left side, and I know that all of this I want to get down to be tangent of theta, just one simple little term. So what happens is I need to think about, okay, tangent is sine over cosine. So if 2 sine of theta, here's what I'm going to do. If I replace sine of 2 theta with 2 sine theta cosine theta, then I need something in the numerator that will somehow make the 2 and the sine of theta disappear but leave cosine of theta. Because remember, tangent is sine over cosine. So here's what I'm going to do. 1 minus. Okay, please remember your identities, your cosine of 2 theta, your double angle identities for cosine involve 2 terms. So the subtraction here is going to be something that can be tricky, or anyway, you have to be careful with it. So I'm using parentheses. Here's what I want us to look at. I'm going to come down here. Your cosine of 2 theta, you have 3 identities to choose from. One of them is cosine squared theta minus sine squared theta. I have another one that is 1 minus 2 sine squared theta. And I have a third one that is, let's see, 2 cosine squared theta minus 1. So I'm going to really think carefully about which identity do I want to replace cosine of 2 theta with. Okay, well, first of all, I know that I need this 1 to disappear. So there's only 2 identities that involve a 1. So it's going to have to be 1 minus something. So I know that I'm going to not use this one. Sorry, that yellow is not very good color to use there because you can't see it. I know I'm not going to use this one. So I'm also going to be thinking in terms of, okay, should I try this identity for cosine of 2 theta, or should I try this one? Well, remember what we're also wanting to happen with sine of theta in the denominator. We need it to disappear. So let's try this middle identity that I have listed here. If I replace cosine of 2 theta with 1 minus 2 sine squared theta, and I do some cleanup on the numerator, let's see what happens. Removing the parentheses by subtracting, I'm going to have 1 minus 1. And when you subtract negative 2 sine squared theta, you get plus 2 sine squared theta. And all of that is over 2 sine of theta cosine theta. And then notice that in the numerator, my 1's will definitely cancel. So they're gone. I have 2 sine squared theta over 2 sine theta cosine theta. And now what you've got is you've got a monomial, meaning one term in the numerator, and you have a monomial in the denominator. And so now you can cancel parts of monomials. So your 2's are going to cancel. You have a sine squared theta in the numerator. You have a sine of theta in the denominator. You can reduce those, be left with sine of theta in the numerator. You have your cosine theta in the denominator and sine of theta over cosine theta. Guess what is tangent of theta? So, recognizing that we had a double angle for cosine, we had a double angle for sine, that's what I use to help me decide where to begin this process. I think that the identities that are K, L, M, and N, I think these are easier to work with than the identities that were A through E, because K through N kind of gives you an idea of where to start the process. A through E, you're just kind of stabbing in the dark at trying to decide where to begin proving those identities. I would not worry about the identity for M. That one's a little complicated, so don't worry if you don't. If you don't understand M, don't fret, don't stress over that. And when I scanned the work, there is a half angle identity there, I think, that I've used. Please ignore that one as well. N is your last identity that that I want you to look at in terms of lesson 1. So, don't stress if you don't get this at the very beginning. I encourage you to make sure that you look through the examples and where I've worked them out. And as you try to do some of these in the assignment that is attached to the notes, go ahead and look at the work that I've provided and just kind of follow along with those as you're working through them. These only get easier the more you practice them. And this is a prime unit in which it's going to be very important for you to write things down and just have an open mind as you go through these. If you have any questions, don't hesitate to reach out. So this concludes part 2, and I will see you again. Well, I guess I won't see you, but we'll get back together with lesson 2.